Here we're looking at resistors in parallel, and this drawing shows us three resistors in parallel. They have each have their own current. Resistor 1, I1, resistor 2 has current 2, and resistor 3 has current 3. From Kirchhoff's current law, we know that the total current in this circuit is equal to the sum of the currents. Now if we're looking for the total resistance, we know that the total resistance is equal to the supply voltage divided by the resistance in the circuit. So we can use that equation, and Vs over total current can be expanded out to be Vs over I1 plus I2 plus I3. Now going back to Ohm's law, we know that the current in resistor 1 is the supply voltage divided by R1. Note that all the resistors are connected directly across the supply, so the voltage across each of them is Vs. So I1 is Vs on R1, I2 is Vs on R2, I3 is Vs on R3. So we can substitute into the equation Vs over Vs on R1 plus Vs on R2 plus Vs on R3. We can take Vs outside as a common factor. So now we've got the equation with Vs on top and Vs outside of 1 plus R1 plus R2 plus 1 over R3. So we can cancel the Vs out, divide top and bottom by Vs, and we get the simplified equation R total equals 1 over R1 plus 1 over R2 plus 1 over R3. And that's what we're looking for. What's the total resistance in this circuit? So here we have it, total resistance, and if we put some values in here as an example, if Vs is 10 volts, let's find the total current. Now R1 800 ohms, R2 800 ohms, R3 400 ohms. We plug them into the equation, and that equation will give us a total of 200 ohms. We put 200 ohms into Ohm's law, 10 volts divided by 200 ohms, total current 50 milliamps. Now the thing about that circuit is, one of the things we can do with that circuit, once we find RT, is we can simplify the circuit. We've replaced the three resistors of that circuit with one resistor, which is equivalent to the total of the three resistors, in this case 200 ohms. So we can simplify our drawing of the circuit. Okay, let's look at a special case. Let's look at two resistors only. I've simplified the resistor equation. Total resistance is 1 over R1 plus 1 over R2. Now we can't add those two terms on the bottom together because they don't have a common denominator. So let's multiply the first term by R2 on R2, which is just multiplying by 1, which doesn't change anything. And let's multiply the second term by R1 on R1, again, which is just 1, so we're not changing anything. So let's have a look at that multiplied through. So now we've got 1 over R2 on R1 R2 plus R1 on R1 R2. So now we can add those two terms directly together. So now we've got 1 over R1 plus R2 over R1 R2. Now if we multiply top and bottom by R1 R2, we can simplify this equation a bit further, and there's our total. So our total resistance becomes the product over the sum of the two resistances. So here we are, we've got two resistors, 2200 ohms and 4700 ohms. We plug them into the equation, 2.2k times 4.7k over 2.2k plus 4.7k, and if we multiply that out we get around 1500 ohms. Now notice that the final resistance is smaller than the smallest resistance. That's a reality check. If you end up with a final resistance in a parallel circuit, if you end up with a final resistance bigger than the smallest resistance, then you're wrong. You need to find a total resistance that is smaller than the smallest resistance. Let's look at another special case. What if they're identical resistances? So let's put two 2.2k resistors in parallel, put them into the equation, and instead of completing the equation, we'll just simplify that. We end up with 2200 squared over 2 times 2200. We cancel the 2200 out, and we end end up with 2200 on 2. Two identical resistors in parallel, just divide the resistor value by 2. So in this case we'd end up with 1.1 k ohms. In fact, if you have multiple identical resistors, you can divide the resistor value by the number of resistors. So if we had, say, 4 1000 ohm resistors in parallel, then that's 1000 divided by 4, 250 ohms. So that's resistors in parallel.